Okay, so today we are going to talk about recursion. So let me start with what recursion is. So when a method or function, so when a method slash function calls itself, that is called recursive call, and that is what recursion is. So when it calls itself, it is called recursive call, and the whole process is called recursion. So let's talk about why we use recursion. So recursion is used to divide bigger problems into smaller problems. So and it also reduces your code, and it is easier to use in some cases, like when you are traversing through a tree. You have to traverse in order, pre-order and post-order, which if you do without recursion will be a very hard job. And but if you use recursion, it will be very easy. And similar with graph, so BFS and BFS, the all the um, algorithm you use, if you do it without recursion, it will be very hard, but if you use recursion, it will be very easy. So it will be easy, but it is not a good choice, because recursion, it takes a lot of memory. It can, if you do not consider the base case, if your base case is never reached, then the memory will be full. So uh, let's talk about recursion. So what we do is recursion, we divide a big problem into a smaller problem. So what happen is, if let's say, if I want to print from 1 to 10, so what I can do is I can use a for loop directly, and I can print from I from 1 to goes till 10, and I can print all of that. Or I can divide this into a smaller piece. So what I can do is I can print 1, and then I can increase 1. So it, let's say I'm sending 2. So this time I'm sending 2, so I'm printing 2, and then this, and again I'm sending 3 in the same method. So again and again I'm doing the same job, but the code reduces in some cases, not usually. In this case, you can print 1 to 10 in 3 lines, and recursion will take more lines, but for bigger problems, it can help you. So we divide a big problem into smaller problems, and solve those smaller, actually it shouldn't be problem, it should be a part. So we divide a big part into smaller parts, and we solve those smaller parts according to the algorithm required for bigger part. So we have to take care what bigger part is asking, and then we can solve the smaller part. So what recursion has, so recursion has two or three, I consider three, but usually in some books it's only written two. So one is a base case, so you have to find the base case. When will your recursion will stop? This is very important, because if your recursion doesn't stop, it will call itself again and again, and it will eventually, your memory will be full. So base case is important. What is base case? So in this, you have to define a case where the method returns a value. So simply says that method do not call itself. The returning a value is just a statement. Actually, you do not have to call it again inside the base case. So that's what you have to do. And then there is a recursive case. So recursive case is define define a case where you have to divide the current problem into either you divide the current problem in smaller pieces, or you can extend the problem. So I shouldn't use divide, I should use extend the problem into further pieces or further parts. Yes, so that's what you do in recursive case, right? So you have base case, you have recursive case, and the three parts which I was talking about was much similar, but you can separate them also. So it is one, you have to find the base case, which I already talked about. Then you have to find a relation. So you need to find relation between different outputs you have. So the output you are getting, you have to find the relation between them, and if you can find a relation between them, then simply you can create you can write all those relation in this. So just for an instance, I know all of this is not making much sense, but let's say I want to print from 1 to 5. So this is what I want, and my recursive function, what it does, it prints one value at once. So I know that if I'm printing 1, then the next value I want is 1 plus 1, and then the next value I want is 1 plus 1 plus 1 plus 1, which is simply the last value 2 plus 1, and then next I want 3 plus 1, and then next I want 4 plus 1. So this is just an example, right? So I'll write here an example. So this is an example for, and the base case for this will be that if the parameter which I am passing through the recursive method is equals to 5, then is greater than 5, then we have to stop the recursive method. So that's one thing. So this is how you create a relation, and then you have to generalize. So generalize. So you generalize this relation, and how can you generalize this relation? That it's really simple. So you have to write what will be the recursive case, what will be the return statement in the recursive case. So the return statement in recursive case will be calling the method. So recursive method, so you have that, and then you just extend your value. So this is what you do, right? So let's take some examples. So let's print from 1 to, let's say, number, any number. So